Hey guys, right now we're going to work on solving systems of equations using elimination. Okay, and elimination means we get rid of something. So first thing we're looking for is standard form equation. Standard form is the ax plus by equals c. Okay, so we want our equations to be in that form. If I look at my example here, they're both standard form, woohoo. And then we start looking, okay, can I eliminate? Are there equal and opposite variables? And so if there are, woohoo, I get to keep moving forward. If there's not, well, I got to do a little bit more work and that's okay, right? Okay, so I'm looking at my variables. I have negative 6x here. I have positive 5y here. I have positive 6 here and positive 4y here. And I'm looking, are there any opposite and equal variables here? Well, I look at my x's, negative 6x and 6x. Those are equal and opposite. And so I want to use that because I can eliminate, which is the strategy that I'm working on, right? So we're going to woohoo because that one is already ready for us to go. So we're going to take that. Now we're going to add them together. If we already have the equal and opposite, we add our two equations together. So the x's go to 0. That's going to zero out. That's the only way this works. If your variables don't zero out, you got to do some work first, okay? 5y and 4y is going to give me 9y. 1 and negative 10 is negative 9. And then you solve, right? So y is going to be negative 1. Awesome, there's my y coordinate. Halfway there, ooh. Okay, all right, so there we go. Now it's like substitution method. So I take one of my original equations, take one of them. So negative 6x plus 5y equals 1. Always use an original. We're going to substitute that y value I know now for the y value in my equation. So I'm going to have negative 6x plus 5 times, it's now negative 1 equals 1. And we solve for x. So negative 6x minus 5 equals 1. Zero out the 5. If it doesn't zero out, you didn't do it right. All right, and then 1 plus 5 is 6. And now I want to make the coefficient positive 1. So I get x equals negative 1. Okay, so already I'm saying I think my solution is supposed to be negative 1, negative 1. Okay, but you know the drill right now is we always have to check. So we're going to take that negative 1, and we're going to check it into both of our equations. So negative 6x plus 5y equals 1. And we have to check the other one as well. They have to end up true statements. If they're not true statements, oh no, I messed up my work, gotta go fix it. So we plug negative 1 in for the x's and negative 1 in for the y's. All right, so negative 6, use parentheses, times negative 1, times negative 1 equals 1. Multiply, so I get 6 minus 5 equals 1, 1 equals 1. Woohoo! All right, do the same on the other one. Use those parentheses when you substitute in. It'll help with some sign issues. Okay, so I have negative 6 minus 4. Does that equal negative 10? Negative 10 equals negative 10. Awesome, I'm good to go. Okay, so our solution was, in fact, negative 1, negative 1. Okay, that's what we're going to do. We're going to look at a few more examples. If you think you got it, go for it. If you hit a bump, come watch some more examples. All right, so we're looking at another example. Remember, we want standard form, ax plus by equals c. Both of these are in standard form. Cool. Now we're looking, are there any equal opposite variables? 16x, negative 8x. Nope, negative 10y, negative 6y. Oh, bummer, I got to do extra work. Okay, so now what I'm looking for is, well, can I manipulate it to make an equal and opposite one? Okay, and I want to always look for what's the easiest route, guys. Don't overcomplicate math. Look for the path of least resistance. I'm looking right here at these x's. I know that if I multiply this negative 8 times 2, I have negative 16, which is opposite positive 16. Woo, that's what I want. Okay, so here's how it works. I'm going to manipulate. Remember, in math, we can manipulate as long as you don't ruin the balance of it. So I know this times negative 2 will give me what I want. I need to multiply the whole bottom equation, everything, by -2. Because if I, sorry, not -2, by 2. Because if I do that, I've just changed the equation, but it's still the exact same equation. Okay, so we're going to multiply every part of that equation by 2. Okay, these are equal. I just manipulated it. Woohoo! Grand manipulator right here. All right, I'm going to bring this first one down here so that they're together again. Reunited and it feels so good. All right, so here we go. They're together. We're going to use the manipulated one and that original one that we didn't do. We have equal and opposite, so we are ready to add these two equations. Remember, one of my variables should zero out. If it doesn't, then I didn't do it right. So this zeroes out. Over here, -12y and -10y is going to give me -22y. 10 and 12 gives me 22. And you know what to do. We need a +1 coefficient. So we're going to get y equals -1. There's our y coordinate. Halfway there. All right. Now we use that and we substitute in to one of the originals. Original. All right, so if I do 16x minus 10y equals 10, I'm going to swap out y with -1. And then solve for x. Okay, -10 times -1 is +10. I need to isolate that x, so I'm zeroing things out. All right, that zeroes out. Checking my math. Oh, hey, that's a 0 too. Guys, 16 times what equals 0? This has to be 0. Always pause and just ask yourself, do I know this? All right, so here's my x coordinate. Okay, so we're saying our solution, whoa, all my random marks, sorry. Our solution should be 0, -1. That's what we're proposing, and then you know what to do. You got to check. You got to check. So let's check it. So I have it set up, and you do your substitution. X's are zeros now, Y's are -1. Use parentheses to keep track of those signs. Okay, this is 0, -10 times -1 is +10. 10 equals 10. Happy day. Let's make sure the other side, x's are 0, y's are -1. So we have 0. And then -6 times -1 is +6. And we get 6 equals 6. Woo, we are masters. All right, that's it. Feeling all right? If you feel like you got it, remember, go practice. If not, keep watching. All right, so look for standard form in this system. They're both ax plus by equals c. Okay, sweet. Then we look, are they equal and opposite? -4x and x? Nope. 9y and -3y? Nope. Okay, we're going to have to manipulate something. Okay, and this time we have some choices. I could multiply by 4, and that would give me 4x, which is opposite. I could multiply by 3, and that would give me -9y, which is opposite the +9y. You can choose if you have the option. I'm going to go with the 3. Okay, so we're going to do 3 times everything, because remember, we don't want to ruin the balance. So that 3 multiplies times all of that. So I'm going to have 3x minus 9y equals -18. Okay, so I manipulated this one. So we're going to drop that top one down here. So 4x, right? We want to reunite our equations. Okay, all right, I have equal and opposite. Woohoo! So that means I can go into my adding my two equations together. Okay, remember, if a variable doesn't zero out, you did it wrong. So those zero out. Happy day. All right, so I'm left with 3x minus 4x is going to be -x equals -18, and 9 is going to be -9. Oh, I want a positive one, not a negative. So let's make it positive. So x is +9. There's my x coordinate. Sweet. Now we use that. Oh, not what I wanted. Okay. All right, so now let's go plug it in to one of our equations. Remember, use an original equation. I'm going to use this just because it seems nicer, right? Okay, so x, I found x. Make sure you sub into the right place or else we cry sad tears. So I get 9 minus 3, y equals -6, and we solve for y. All right, so I'm going to zero that out. -3y equals -15. I want a +1 coefficient. So divide by -3, y equals +5. Negative divided by negative. That gets me +5. Okay, I'm almost there. I think I know my solution should be 9, 5. And then what do we have to do? We have to check. All right, so let's check it out. All right, so we checked, and I just went ahead, substitute in, do the math. It should be equal. Both of them work out. Our solution rocks. All right, let's look at one more just to make sure we're pros. Here we go, one more. This one adds a little bit extra twist to it. We have 3x minus 2y equals 2, 5x minus 5y equals 10. Standard form, ax plus by equals c, woohoo! All right, then we look, are there equal and opposite? 3x, 5x, oh, bummer, -2y, -5y, nope. And if I look, there's not, I can't multiply just one of them to make it easily equal the other one. So we're gonna multiply both of them. I'm looking, I could go either way. If I multiplied this times 5 and this times 3, we'd get 15, right? Or I can come here and I can see, oh, 2 and 5, I can multiply and get 10, right? So you can choose either way. I'm going to go with our y's. So I'm going to multiply the top equation, everything by 5, okay? Remember that goes to all of it so you don't disturb the balance. 15x minus 10y equals 10. So we're going to use this one, okay? And then I'm looking at my second equation, that 5x minus 5y equals 10, because we're still not at equal and opposite. I want this to be positive 10y, so I have to multiply by -2 and multiply everything through. So we're going to end up with -10x plus 10y equals -20. So these are the two equations we're going to use. So we're going to put those together. I'm going to have 15x minus 10y equals 10. And we have -10x plus 10y equals -20. All right, equal opposite, I'm ready to rock and roll. This is going to zero out. 15x and -10x is 5x equals -10. Divide by 5. X is going to be -2. Okay, once I know that, I'm going to plug it into one of the originals. Always, always use the originals. So I'm plug that in. So 3 times -2 minus 2y equals 2. -6 minus 2y equals 2. Zero this out. Okay, I'm going to just swing up here. Okay, so I'm going to have -2y equals 8. Divide by -2, y equals -4. Okay, so my solution should be -2, -4. That's what I'm proposing, but we gotta check. All right, so let's bust out that check real quick. All right, so there's our check. Remember, you're subbing that ordered pair into the original equations, and you should end up with true statements for both of them, okay? Because our solution means that it makes both equations true at the same time. This would be our point of intersection if we were to graph them. You can see that both of these worked out. My solution is the point -2, -4. Happy days. That is the elimination method. So use what you've seen, rewatch if you need to, and go practice. You got this.